Welcome to The Explainer. When we think about data analytics and visual design, we usually picture it as this purely technical, computer-driven task, right? Just crunching numbers and plotting points. But what if I told you it's actually a human psychology task? Seriously, creating effective charts and dashboards is entirely about understanding how the human brain works and figuring out how to hack it so your message lands instantly. Okay, let's jump right in with a little test. Take a look at these two orange circles. Which one of them is larger? The one on the left, surrounded by those massive circles, or the one on the right, surrounded by the tiny dots? Take a guess. Well, it's a trick. This is the classic Ebbinghaus illusion. Those two inner circles, they are exactly the same size. No way, right? I absolutely love starting with this because it proves right out of the gate that our eyes naturally deceive us. If our own perception can be tricked that easily by just a few simple shapes, imagine the high stakes of bad visual design when you're communicating critical data. If we aren't careful, we aren't just confusing our audience, we're actively misleading them. To make sure our visualizations are actually communicating the truth, we need a roadmap. Here's exactly what we're going to cover today. First up, the speed of sight. Then, perception versus cognition. Third, hacking pre-attentive attributes. Fourth, the Gestalt principles. And finally, we'll tie it all together by designing real-world dashboards. Let's get into it. Section 1. The speed of sight. How fast do we really see? Think of the theories we're about to discuss as your personal toolkit to basically outsmart human biology and dramatically reduce the mental effort it takes to understand data. When you really think about how we process visual information, it is honestly staggering. You know that old saying, a picture is worth 1,000 words? Well, it's also processed in about 13 milliseconds. It's literally a flash. When you look at a screen, this highly complex chain reaction happens instantly. Your eyes take in the raw input, the visual cortex processes it, you hit pattern recognition, memory is engaged, and bam, a decision is made. The really fascinating part here is that your brain detects patterns long before it actually reads any specific details, labels, or text. Your brain is just this highly tuned pattern recognition machine. So the faster a visualization can trigger that pattern recognition, the more successful it's going to be. Section 2. Perception versus cognition, the fast and slow brain. Now that we know how blindingly fast the eyes can work, we really need to talk about this massive biological gap. On one side, we have perception. This is simply seeing. It's completely automatic, it's incredibly fast, and its whole job is just to detect patterns. But on the other side, we have cognition. This is understanding. Cognition is analytical. It is significantly slower, and its job is to actually explain those patterns. Let me give you an example. If you glance at a chart and instantly notice that one bar is way taller than the rest, well, that's perception. Your fast brain did that completely effortlessly. But when you look a little closer, read the axis labels and conclude that, oh, sales increased this quarter. That is cognition. Your slow brain had to do all the heavy lifting there. So here is the absolutely crucial point to take away. Visualization should reduce cognitive effort rather than increase it. Think of good design as a cheat code. Your cognitive brain is kind of sluggish, it's analytical, and frankly, it gets easily overwhelmed by way too much information. If you design your charts effectively, you actively shift that burden away from the slow cognition and push it onto that lightning-fast perception. Section 3. Hacking pre-attentive attributes. Directing the eye instantly. So, if we actually want to use that cheat code we just talked about, we have to understand what our fast brain looks for before conscious thought even kicks in. Picture 3 bars representing data. 2 of them are just a neutral gray, but one is highlighted in bright red to show a massive spike in the numbers. Without you even trying, your eye immediately locks onto that red bar. Right? You didn't read anything, you didn't analyze the scale. The color alone manipulated your pre-attentive processing to totally command your focus. Color isn't our only tool, though. Here's the full list of these pre-attentive attributes. We've got color, size, shape, position, orientation, and motion. You could use a larger bubble and a scatter plot to draw attention using size, or maybe position key elements at the top left to establish a hierarchy. But listen, here is a critical design tip you have to remember. You must use these features sparingly. Seriously, if everything is big and red and moving around, nothing stands out. It's just noise. You have to use these attributes deliberately to create a clear visual hierarchy and guide your viewer's eye exactly where you want it to go. Section 4, the Gestalt principles, how we naturally organize visuals. Okay, so once you've successfully grabbed the viewer's attention, how do they process the rest of the layout? Well, this brings us to proximity. And the rule here is brilliantly simple. Objects placed close together are perceived as belonging together. If you're building a dashboard, simply adjusting the spacing between your sales values can mentally group them by region for your viewer. You don't need to draw heavy boxes, you don't need to add extra text labels, just put related things closer together and let the viewer's brain do the rest of the work. Next up is similarity. This means objects with similar color, size, or shape are automatically grouped mentally. For example, if you use a consistent shade of green for all your revenue-related charts across an entire dashboard, your viewer just effortlessly ties that data together. They intuitively know, okay, green means revenue, without having to sit there and reread the legend on every single graph. It just flows. Then we have continuity. The eye naturally wants to follow smooth paths. This is exactly why line charts are so incredibly effective. They exploit our brain's love for smooth visual flow, which allows us to effortlessly track trends over time. When we design, we really want to avoid putting in unnecessary breaks, heavy grid lines, or sudden visual stops that interrupt that nice, smooth flow. And now for one of my absolute favorites, closure. The brain will automatically fill in missing information. If a shape is partial or an outline is incomplete, our brain literally finishes the drawing for us. This is a massive advantage for us as designers because it means we can get away with minimal design. We can strip away extra borders, axis lines, and background clutter because the viewer's brain will naturally complete the necessary boundaries all on its own while enjoying a much cleaner, less overwhelming visual experience. Section 5, Designing Real-World Dashboards. High-stakes data design. We've talked a lot about psychological theory so far, but what actually happens when cognitive load limits are tested out there in the wild? Well, first, we have to look at what to avoid. When you overwhelm a viewer's short-term memory, their interpretation just completely distorts. So you absolutely must avoid overcrowded dashboards, excessive text, 3D charts, inconsistent legends, and overlapping labels. 3D charts, for instance? Oh man, they are notorious for perceptual errors. They add this completely unnecessary dimension that totally warps how we perceive size and proportion. The brain simply cannot accurately compare a slice way in the back of a 3D pie chart to a slice right in the front. It just doesn't work. Color psychology is another really critical factor here. We have to use colors with real purpose. Think about it. Blue naturally communicates trust. Green implies growth. Red signals a warning, and orange demands your attention. And gray? Gray is your absolute best friend for neutral baseline data. But remember, while color is great, you also have to ensure sufficient contrast so that your dashboard is actually accessible to everyone. Let's apply our new cheat codes to a really high-stakes scenario, a healthcare dashboard used for patient monitoring. In this kind of environment, a doctor's cognitive load is already maxed out. So which colors communicate urgency here? How must the layout be structured to immediately highlight critical patient metrics? Well, by using bright red for warnings and utilizing proximity to group a single patient's vitals closely together, you actively reduce the decision time for that doctor. And in this context, reducing that time could quite literally save a life. Or consider an agriculture dashboard for crop monitoring. What metrics does a farmer actually need to see first? Is it the NDVI vegetation index, the rainfall, or the temperature? Ultimately, the primary user dictates the design. You must deliberately choose which data points get that pre-attentive emphasis based on the farmer's immediate daily needs. This means pushing those less urgent disease alerts or historical data sets right into the perceptual background. And that brings us to the end of our explainer. I want to leave you with a bit of a challenge. As you sketch out your next design blueprint, really think about the biology and the psychology we discussed today. When you build your next visualization, what will your audience's eyes notice first? Is it going to be your key insight, or is it just going to be random clutter? The psychology is completely in your hands. Thanks for joining me on this exploration of the visual brain.